Hello everyone, welcome back to our channel. Today we are going to learn about how to predict the compressive strength of concrete using support vector regression model. In this video, we will cover everything from data import, data pre-processing, model training, model evaluation, and even saving the model for future use. Within the model training, we will also cover hyperparameter tuning using grid search methodology. Before we dive deep into today's tutorial, I have a small request. Behind every video, we do a lot of hard work to give you the best content. If you like our content, please subscribe to our channel. Your subscription means a lot to us and it really motivates us to create more useful tutorials like this. Let's dive into today's tutorial. First, we import some important libraries for our project. This includes NumPy and Pandas for data manipulation, Matplotlib for data visualization, and some special functions of sklearn library for performing some operations like data preprocessing, hyperparameter tuning, and ML model building. And finally, we import joblib library for saving the machine learning model for future use. Here we import our data set of concrete compressive strength from this Excel file. So this data is obtained from UCI machine learning repository. So I have just downloaded that Excel sheet and kept it in my local directory. So here I am loading the Excel sheet using this read Excel function and saving it into a data frame. DF. So overall, if you look at our data, this is how our data looks like. So it has 8 input features and 1 output feature. The 8 input features are cement quantity, blast furnace slag, fly ash, water, superplasticizer, coarse aggregate, fine aggregate, and age. And the only one target quantity, that is the concrete compressive strength. Overall, we have 1030 samples in our data set, of which these columns represent the total number of features, both input and target features. Here we convert the pandas data frame into NumPy arrays for easier manipulation and compatibilities with several sklearn library functions used for data pre-processing and machine learning model building, etc. So if you look at here, after converting the data frame to a NumPy array, I am further splitting the NumPy array into two sub NumPy arrays. Here X represents the input features. So the first 8 input features are stored in this X variable, and the last target feature is stored in this Y variable. If I look at the dimensions, so input features are of 1030 by 8 and target feature is 1030 by 1. And here is our main code. Here in this cell we do the main model building and testing activities. Here we first initialize the R2 variable to 0. So we will use this variable later to store the R2 score value. Next we created a loop, while loop, that continues training the model multiple times until the R2 score is greater than 0.9. This means that the loop will keep iterating until the model achieves a satisfactory level of performance, and here in this particular tutorial the performance is defined by this R2 score. Once this R2 score reaches this 0.9 equals to or greater than 0.9, so we terminate this loop. Inside this loop we first split the data into training and testing sets using this train test split function of sklearn. Next, the training and testing data are scaled using this standard scaler function. Scaling means adjusting the numbers in our data in such a way that all input features are in a similar scale. So you can imagine the scaling operation just like making sure all the lengths in a set of measurements are in the same units. You can imagine like that. For SVR, this scaling operation is very crucial because SVR treats all features equally when making predictions. So if that is the case, if some features have much larger values than the others, they might dominate the prediction process. This scaling process ensures each feature contributes fairly to the final prediction, making our model more accurate and reliable. Next, here we initialize some hyperparameters, and then we do grid search using this grid search CV function to find the best combination of hyperparameters for SVR model. Hyperparameters are some sort of settings that we set before training. These hyperparameters are not learned by the model during training. These have to be set before the training itself. In this case, the hyperparameters that we defined here are C, gamma and epsilon. These parameters are specific to this radial basis function. kernel of SVR. If you use another kernel, you have to choose other hyperparameters. So overall, these specific hyperparameters are specific to this RBF kernel. This grid search exhaustively searches through all possible combinations of these parameters and evaluates each combination using a cross-validation technique. Using cross-validation. So here we have defined five-fold cross-validation. You can use any other number also, so that's not a problem. And after that, we use this R2 score metric for evaluating the best parameters. Once these best hyperparameters are identified, we then construct a SVR support vector regression model with these parameters, and we train the model using this scaled train data. The trained model is then used for making predictions on the scaled testing data, that is this one. Then we evaluate the R2 score. Here, a score of 1 indicates a perfect fit, but in practice, any value greater than 0.85 can be considered to be a best fit. The calculated R2 score value is then printed along with the best hyperparameters found during this grid search. Once the R2 score exceeds 0.9, we will terminate this loop and then we will continue with the hyperparameters obtained in the last iteration. Overall, in this particular case, we took overall 16 iterations to achieve this 0.9 R2 score. Here we visualize our model's predictions of concrete compressive strength against the real compressive strength values with respect to all input features. So here in this cell, we just compare the concrete compressive strength against the cement quantity and blast furnace slag. So these are the first two plots. So if you look at the predictions are not that poor actually. So they are decent. And here in this cell, we continue plotting the concrete compressive strength values against all other variables in the data. So apart from these two, cement quantity and blast furnace slag, we have 6 more parameters like fly ash, water, superplasticizer, coarse aggregate, fine aggregate, age, etc. So overall, if you look at all these plots, our predictions are decent. Once we are done building our model, then we will save the trained model using this joblib library. So along with the developed model, we are also saving the scalar object. This object has been saved to maintain consistency in pre-processing during future predictions. Means that we have to use this scalar object to scale the new input features before using them for predictions. We will see how to use this saved scalar object in scaling the new input features in a minute. Now that we have trained and saved our model, including the scalar object, let's see how we can use it to make predictions on new data. Here in this Jupyter notebook, we load the previously saved SVR model and the scalar object using this joblib library. Let's create a new input feature representing a different concrete mixture that is not present in any of the training and testing data that we use to train and test our model. Each value in this array corresponds to a specific feature of concrete mixture, such as the quantities of cement, water, coarse aggregate, fine aggregate, etc. Here we first pass the input feature to the loaded scalar object. Then once the scaling operation is done, we pass the scaled input feature to this SVR model. So YP gets the predicted concrete compressive strength. So here I am printing the concrete compressive strength value. So our prediction is 51 MPa excluding this decimals. So overall our prediction is 51 MPa. So that's it for this tutorial. So this is how we train and test the model using support vector regression, and this is how we find the best hyperparameters using this grid search algorithm. So these are all some concepts that we have learned in this tutorial. So if you have any questions, feel free to ask in the comment section. We are happy to help you out. If you like our content, please hit the like button and subscribe to our channel. Happy learning. Thank you.